In this video, we'll learn how to solve inequalities and how to graph them on a number line. Solving inequalities is just like what we do when we're solving equations. We separate out our equality or inequality symbol, and then I want to isolate my variable. So in this first example, we have p plus 4 is greater than or equal to 9. The opposite of plus 4 is minus 4, and what I do to one side I have to do to both sides. So here I have p all by itself because that positive 4 and the negative 4 cancel each other out. I keep my same inequality symbol, and then I'm going to do 9 minus 4, or a positive 9 and a negative 4 combined would give you a positive 5. This is called my solution set, which is different than a simple solution for an equation because it means that there's a set of numbers that could make this inequality true. P could be 7 because 7 is greater than or equal to 5. P could be 20. P could be 1,000,000. It could be so many different things. It's a whole set of numbers that could work as opposed to just one. Here I separate out my inequality symbol. I see that j is being divided by 3. The opposite of dividing by 3 is multiplying by 3. 3 times 3 divided by 3 cancels out to 1. 1j, keep my inequality symbol. I have to multiply times 3 on both sides. Negative 8 times 3 is negative 24. So here's my solution set for this inequality right here. So once you have your solution set, you'll then need to know how to graph these inequalities. So here are my two solution sets. The first thing that I do once I have my solution set is I decide what kind of circle am I going to need to put on my number line. For this one here, I've got a number line. I'm going to make some kind of circle at 5. And for the second one, I'm going to make some kind of circle at negative 24. Here's how I remember what circles go with what. This greater than or equal to symbol takes me 2 steps to draw. One is the greater than or less than symbol. The other is the or equal to symbol. This circle takes me 2 steps to draw. One for the circle, 1 step to fill it in. So it kind of looks like a little emoji face. The very sleepy, yawning emoji has the lines underneath its eyes and a filled in mouth. So this is called a closed circle. A closed circle means that your number, the number it's on that you've circled, could possibly be the answer to the inequality. So you could be exactly 5 years old in this situation, or you could be greater than 5 years old. In this inequality over here, where I just have a less than or greater than symbol, in this case I have a less than symbol, these symbols take me 1 step to draw, just drawing those symbols. Same with an open circle. I don't need any extra effort to fill it in. So I have step 1, solve your inequality. Step 2, decide on the type of circle. Are you going to have a closed circle or are you going to have an open circle? Put your circle at your number line, at the number from your solution set on your number line. Step 3. Now it's time to pick points to check from your inequality solution set. So we had 5, we had P is greater than or equal to 5. We have a closed circle at 5. All right, now I'm going to pick 2 numbers, one that's bigger than 5, let's say 10, and one that's smaller than 5. I'm going to choose 1. These are my 2 numbers. One of them should make this solution set true. So I'm going to check them. It's very important for you to check your two possible numbers. It's also important to recognize that this right here is your answer. It's not going to be this or this. Your actual answer should have one variable and one number and one either equal sign or inequality symbol, depending on the type of problem you're doing. But step 4 is for me to check if these actually work. So, is 1 greater than or equal to 5? No, 1 is smaller than 5, which is less than 5, not greater than. This one does not work. Is 10 greater than or equal to 5? Well, it's not equal to 5, but 10 is greater than 5, so this one does work. Step 5 is to draw your arrow through the side of your number line that has a solution that works. I like to draw my arrow a little bit above the number line because sometimes if you draw it right on the number line, especially if the number line is printed for you and your pencil kind of looks like the same ink, it's kind of hard to tell if there's actually something drawn there or if it's just, maybe a mistake in the printing. So I like to draw my arrow a little bit above the number line so it's very clear that I know which direction it's going in. Let's try it for the other solution set. So we have j is less than -24. Less than means an open circle. I'm going to pick numbers that are bigger and smaller than -24. Let's see. 0 is bigger than -24. And -100 is smaller than -24. We have to remember about negative numbers. They do kind of like the opposite of what positive numbers do. In positive numbers, 24 is smaller than 100. But these are negative numbers, so the opposite rules apply. -24 is actually bigger than -100 because the bigger numbers are on the right-hand side. Anything going to the right gets bigger. Anything going to the left gets smaller. So those are smaller numbers. All right, let's take those arrows out because we don't want to accidentally confuse ourselves with the direction of our arrows. Okay, there are my two numbers I'm going to check. Great. Actually checking them. Step 4 is 100, -100, less than -24. Yes or no? Well, if they were positives, the answer would be no. 100 is not less than 24. But since they're negatives, the opposite applies. Yes, that's true. Let me check the other one. Is 0 less than -24? Nope, 0 is actually bigger than -24. That one does not work. So your arrow, step 5, is going in the direction of the number that makes your inequality true. Most frequently, you will see a problem like one of these, especially on the basic skills of your quiz and your coming up exam. But sometimes you'll be asked to do the opposite. So instead of me giving you r divided by 4 is greater than or equal to 9 and having you solve it, the opposite of divided by 4 is times 4 times 4. R is greater than or equal to 9 times 4 is 36. All right. My inequality symbol here tells me that's going to be a closed circle at 36. 50 is bigger than 36 and 0 is smaller. I'm going to check, is 0 greater than or equal to 36? It's not equal to, but 0 is also not greater than 36. No, that one doesn't work. Is 50 greater than or equal to 36? It's not equal to, but 50 is greater than 36. Draw my arrow this way. That's your most common type of question, but you might also see a reverse one where I give you a graph and I say, hey, based on this graph, what is the inequality that this graph is representing? Here's how you do that one. In every inequality, you need a variable and you need the number that the circle is on. So here I have b and 9. I know based on that open circle that I'm either going to use one of those two symbols. So to check this, what I'm going to do is I'm going to say, hey, I see that my arrow is going this way. What number might be to the right of 9? 20 could be to the right of 9, right? So now I'm going to replace B with 20. I have 20 and 9. Which of these two symbols would make that an accurate statement? Greater than. B is greater than 9. Let's try another one. If B was 50, is 50 greater than 9? Yes, it is. Okay, here's the thing that sometimes people get confused by. Sometimes people would box this or this as their answer. That's true, but that doesn't represent the whole thing that you see graphed on this number line. That's one number that you're proving is greater than 9. I want to say that all the numbers that are bigger than 9 could possibly be my answer for B because I see that all of them are covered with this arrow. So your actual answer needs to have the variable and the number in it. But that is how you would go backwards from a graph to an inequality.